For more than a century, the small western Wyoming town of Kemmerer was an energy community. Now, thanks to a new company called TerraPower, Kemmerer will remain Energy Town for decades to come. TerraPower is building a new nuclear power plant, a new style, a new economy, a new technology, right here in Kemmerer. I'm Steve Peck of Wyoming PBS. This is Wyoming Chronicle.
Funding for Wyoming Chronicle is made possible in part by Wyoming Humanities, enhancing the Wyoming narrative to promote engaged communities and improve our quality of life, and by the members of Wyoming PBS. Thank you for your support.
For more than 70 years, Wyoming has been a big producer of the fuel for nuclear energy, but never the site of nuclear power generation itself. But that's about to change thanks to a new company backed by one of the richest men in the world. In June, just outside the small Wyoming town of Kemmerer, the plan began its transformation from the drawing board to the construction site.
Thanks so much for joining us all here today for the groundbreaking of America's next nuclear power station, Kemmerer Unit 1.
Following introductory remarks came the ceremonial groundbreaking for what the new company, TerraPower, promises will be the first of numerous new generation nuclear power plants, built with three big advantages over the old ones: quicker and cheaper construction, more efficient operations, and providing both bountiful electricity and backup storage for the power grid. The new plant is scheduled to go online in less than a decade. Key to the TerraPower model, called Natrium, is a cooling core not of water, which must be kept in a high-pressure containment vessel as it boils, but liquid sodium, which only boils at temperatures hundreds of degrees higher than the nuclear fuel ever reaches. So, no pressurized containment vessel is necessary. That's a significant safety and operational breakthrough, resulting from development and testing funded by one of the world's wealthiest men. He was in Kemmerer for the ceremonies.
You know, the number of things that have come together to get us to this day and that need to continue to come together to get us to the next big milestone, which will be inaugurating the nuclear plant, it's pretty unbelievable. Both leaders at every level of government and lots of private companies.
After the speech-making and groundbreaking, two principal figures at TerraPower sat with Wyoming Chronicle at the Natrium site: President Chris Levesque and Natrium's day-to-day project leader, Tara Nider.
I'm a Senior Vice President at TerraPower and the Project Director for Natrium, which is basically I'm responsible for Natrium and everything that goes with it.
Chris, what is Natrium for viewers who haven't heard yet?
Sure, Natrium is the name of our advanced reactor design. We're building the first one here in Lincoln County, Wyoming. Natrium's also a word in many languages for sodium.
My high school Latin kicked in.
That's right,
Yeah.
That's right. And on the periodic table, sodium is Na for natrium, which is Latin for sodium. And we called it Natrium because it's a new kind of reactor. It still takes advantage of fission. We break uranium's atoms in half, which give off heat. But instead of cooling it with water, we cool it with a liquid metal.
Why is that better?
It's better because sodium has a very high boiling temperature, around 900 degrees centigrade. That lets us operate the reactor at a very low pressure. We operate the reactor at 500 C, so we're 400 degrees centigrade away from boiling. And in contrast to today's reactors, which are water cooled, we all know water boils at 212 Fahrenheit, 100 C. So it's not really an ideal coolant because you have to worry about what happens if it vaporizes. And there's been examples of that, for example, at Fukushima. Our plant, because of that 400 degrees difference between operating plant and boiling temperature, has a huge margin for safety, and it also gives you a situation where you need no operator action. to keep the plant safe if you have some kind of natural event.
See, I think so many people still have old and maybe even antiquated ideas about what a nuclear power plant really is. But Tara, am I right in saying that some of these almost cliched worries about a nuclear power plant really are not even relevant to what you're doing here with Natrium?
When the original nuclear plants were designed, we didn't have the benefit of the advanced technology that we have today. So we do a tremendous amount of analysis before we license and construct the plant. The difference really for us, we call it an advanced reactor, is that we're not using the water as the coolant, and the plants are designed so that they're inherently safe, meaning that we're not building something that where something could go wrong with the reactor and then building safety systems around those to mitigate the risk of that. Instead, we're designing the reactor so that in the event that something is a bit off, like the power is a little higher than it should be, the temperature is a little higher than it should be, the reactor naturally, through basically natural forces, brings the temperatures and the reactivity back down. So you don't need any operator to push a switch. You don't need any external power. Nobody has to open or close any valves. It just will shut itself down.
Closer to home, you talked this morning in your formal presentation, Chris, about what this means, frankly, to Kemmerer, the town of Kemmerer, to Lincoln County, Wyoming, here in the West. It's been an energy town for more than 100 years. It's going to continue to be, isn't it?
It is. Just down the road, the Natrium Power Station just celebrated its 60th anniversary of generating electricity. And between here and Evanston, we have 300 megawatts of new wind power. As we mobilize today, we will have a continuous construction presence at this site until construction is completed in 2030. And then, of course, in the history repeating itself scenario of the Natrium power plant, we'll run this plant for 60 or more years. Tara and I feel the same way about this. We love working in Wyoming because of the culture here is so self-reliant. I mean, people know what energy projects are. They're very energy literate. There's many craft workers. People in Lincoln County, Wyoming, they know where the electrons come from when you plug something into the wall. And that's not the case everywhere in the country.
The term I think you used in your remarks was the energy IQ in Wyoming. It's higher than it is in some places. Wyoming Governor Mark Gordon has committed state funding to the preservation of traditional fossil fuel industries in Wyoming. But he's also made sure the state is receptive to new energy possibilities, a point he stressed in Kemmerer.
There have been many people that have come to the state and said, here's what our plans are. We always are open for anything to do with energy, and I have said over and over again, if you're going to do something about energy, you're going to do it in Wyoming. Best solar, best wind, best water. We are the source of nuclear material, nuclear fuel, and that's all very, very exciting. There was an understanding, and I'll make this really clear. At this time in our country, we are expecting and experiencing tremendous amounts of growth in electrical demand, not only from data centers and AI, but also from electrification of almost everything that we do. That demand has increased in ways that we have not seen before. Early on, when we faced some of these energy challenges, it was simple to replace incandescent bulbs with, light-emitting diodes. We could find power in lots of places with efficiency. We're not done with efficiency, but we need generating capacity. What worried me for Wyoming is when you talk about different sorts of energy supply, what are the ones that are going to keep communities alive? What are the ones that demonstrate a commitment to community? And it's things like Natrium that are going to make the difference, which is why our university also stood in the breach and said, you know what, we'll pivot. We need to understand more about what we can do to facilitate nuclear energy, whatever that technology might be. So we have pivoted not only with our community colleges, but with our university to support this effort. And in that process, we also engaged with Idaho National Nuclear Laboratory. So you see, forces have aligned. Growth is happening. Change is happening, not because we're saying to people, you can't do this, but because we're saying, who's going to stop us? I have learned that good things come to those who wait. But you better hustle while you're waiting.
Our TV station is headquartered in Riverton, which was billed itself, I think accurately, as the uranium mining capital of North America for 30 years or more, and this is now a generation back. But a lot of people have said, well, it makes sense then that Wyoming ought to be the place, ought to have a role in nuclear power, possibly, besides just digging up the material and sending it away. Even that, though, is not all that similar to Natrium now, is it? What's the fuel for the Natrium project? Where does it come from? How much of it is there going to be?
We use something called HALEU, which is high assay low enriched uranium. So it's very similar to what's in the nuclear plants that are running today, except the percentage of the radioactive uranium is higher. So while the other plants run around 5%, we go up as high as 20. And that enrichment capability is getting developed within the United States through opportunities with the U.S. Department of Energy.
So we're breaking the same uranium atoms.
Yeah, sure, that's how it works.
Yeah, just like nuclear energy has been done for 60 years. And you know what, I do want to say something about today's plants. We have, I think, 94 in the U.S. and over 400 around the world that are based on this American fission technology. They're very safe. In fact, we need them to continue operating. What we're saying about Natrium is it's safer, it's cheaper, and it also has this new attribute of energy storage, which if we're expanding wind and solar, Natrium's going to be a much better companion for the renewables.
Expand on that a little bit, if you would, this storage capability.
You know, renewables are intermittent, right? The sun and the wind come and go throughout the day. We're big supporters, and our chairman's a big supporter of a massive expansion of renewables. But there's many studies showing that because they're intermittent, you need to add storage with things like grid scale batteries, and you need to overbuild capacity of wind and solar because they're not always running, and that's not always the best use of materials and land. So there's one study after another now that are showing the optimum percentage of nuclear on a carbon-free grid is something like 20 to 30%. And that's pretty widely accepted. And then the thing that's different about Natrium is we're not just providing the base load that you've always known nuclear for 24/7. We store heat in large tanks of molten salt that we'll have here on the site that let us boost power when the sun goes in or when the wind's not blowing. And that's when the electricity is the most valuable.
One of the attributes you mentioned as well for your plant was, you've talked about the price, about the safety. You've received regulatory approval to begin what? What were we seeing groundbreaking for today?
What we have today is groundbreaking for our test and fill facility. So that's a facility that will basically be testing some of our equipment at full scale before it goes into the reactor. These are prototypes essentially. So they will be tested in sodium in the medium that will be used in the reactor. We'll test our pumps, we'll test our control rod drive mechanisms, which control the reactivity of the plant, and also our fuel handling equipment. So it's really an extra test to make sure that things are going to operate the way that we want them to.
On top of everything else, it's also an installation. There's going to be an office, and there's going to be water pipes and lights and that sort of thing too. The energy producing component of it, permitting for that comes later, but you're feeling entirely optimistic about that as well, right?
Yeah, Terra's team did an amazing job on what we call the construction permit application. You know, the NRC is a pretty tough regulator. Their job is to protect people and the environment. And so for them to accept and docket an application they did for us last month, requires a lot of rigor. We had 1,000 engineers working for Terra over a year on that application.
1,000.
Yes, yes.
Yeah, some of them were TerraPower, some were Bechtel, and some were General Electric.
You mentioned Bechtel, they're the construction partner for well-known name for industrial construction around the world.
Yeah, and General Electric.
General Electric
General
as well.
Electric is our design partner. TerraPower and General Electric are basically working on the nuclear aspects of the plant, while Bechtel does more the civil and the energy island.
So the word demonstration gets tossed around in what the project is. What are we trying to demonstrate here in the years to come?
So the Department of Energy named this program the Advanced Reactor Demonstration Project. And the word demonstration means commercial demonstration. So that means this isn't a test reactor, this isn't an experiment. For us to get approval and the very large grant we won from the Department of Energy, it meant this was ready to go build a commercial unit that will someday be owned by a utility that sells the power. So demonstration means commercial demonstration.
Yes. 10 years from now, for example, if the plant is up and operating as you're intending it to, we'll be generating power, correct?
That's correct.
Who gets that power? Where does it go?
We will have a power purchase agreement with PacifiCorp, and that power can go anywhere from here to Northern California. There's 6 states that it goes to, and eventually PacifiCorp will probably be the owner-operator as well.
What are they looking for in this demonstration? Not ask you to speak for them entirely, but what you're wanting to show the utility is
The utility is regulated, so the key thing for the regulator is that they're getting value for what they're really basically providing the best cost of electricity for their ratepayer, and they're also getting clean energy.
Almost any utility in the U.S. wants nuclear energy. It's pretty accepted that you need 20 to 30% nuclear. There's a lot of experience with nuclear on the grid. But there's been a problem that these first projects are too difficult to structure. So technology is a big part of the answer here, to have a cheaper, safer, and another aspect of our technology, the storage we talked about, is hugely important. But then the technology part is only half the problem. The other problem is how to structure a project with a utility, because most of the utilities in the US are regional. They sell their power to ratepayers who really shouldn't bear the cost of a first-of-a-kind reactor. So people in Wyoming and Utah shouldn't pay for those 1,000 engineers, okay? They should pay for the value of the electricity that they'll get for 60 years. So when we transferred the plant ownership to PacifiCorp, that's what the Wyoming ratepayers will pay for. The 1,000 engineers and the learning curve and the construction uncertainty, that will be borne by our investors.
So there's innovation, in other words, in the commercial transaction as well, not just in the hard science of it.
The regulated utilities struggle with nuclear construction because it does take some time. It is you're not going to put a nuclear plant up in a year.
But this promises to be a shorter construction time than the kind of plant we see with the big cooling towers that was built 30 years ago, 40 years ago.
That's right, and it's the advanced technology enables this because it's a low pressure plant. Things can be lighter. We don't need the very heavy containment building with rebar this thick. It will of course be very safe, but if you're not holding in high pressure, there's some steel and concrete you don't need, and there's some safety systems you don't need.
One of the things we have, a special feature of Natrium, is we call one portion of our plant the nuclear island and one portion the energy island, and they're decoupled because the sodium from the reactor heats up salt, and that salt is transferred over to the energy island, and then the salt is used in those tanks to run the turbines and generate power. So the advantage we have is that all of that portion of the plant that is not the nuclear island, we can build before we have our construction permit approved by the NRC, so we can get a head start
that wasn't
on
true
those
in the past.
non-nuclear parts.
And before, it all had to be signed, sealed before it could be delivered.
That's
This
right.
time we're building it in phases. One of the long-time concerns, topics of conversation with nuclear power is nuclear waste. What is the waste profile of your project? How much does it produce? How are you handling it?
I mean, to talk about our waste story, you have to start with the waste story on the existing nuclear power plants in the US. 94 of them, been running for decades, 50 plus years. No smokestack at a nuclear plant. The entire waste stream could be contained on one football field, something like 10 meters high. Is it hazardous? Yes. Sure. But do you have complete accountability for every used fuel rod? Can it be stored safely? Totally. Now, we do need the Department of Energy to settle on a final geologic repository for it. So the story for Natrium is pretty much the same, except we generate 2/3 less volume per power unit generated. And we can do that because advanced computing allowed us to design this core with very precise physics, so we can burn the fuel more completely, so there's less fuel at the end of the day.
And the waste that is produced will be kept here, or
On site to begin with, and that'll be in storage casks that have been used for the light water reactor. Very similar to that.
nothing new to that?
Nothing new to that.
Not really hard to store nuclear waste, is it?
I spent most of my career in dry storage for nuclear materials, and they're extremely safe, they're extremely reliable. Not much happens to them, not much at all.
Yeah, Tara's an expert on used fuel storage, and whenever I think of it, and I've told a lot of people in Wyoming this, when I was a submarine officer and I lived on a submarine base with my young family, we had used nuclear fuel stored just a block or so from my house. My 10-year-old could ride his bicycle pretty much up to the shielded container, the kind of container that Tara's company used to make.
Interesting. What was your background before TerraPower?
Got my engineering degree as mechanical engineering at MIT, and then I went through a couple of companies, but most of my career has been with the Areva companies, which is now Orano, but I also worked at Westinghouse and Constellation, always nuclear. And then 8 years ago I came to TerraPower, and I'm not disappointed.
Now, Chris, you have a military background, among other things, including a military assignment that included nuclear energy. What was that?
That's right. So I started my career as a Navy submarine officer, and that's where I learned about nuclear power.
Navy submarine.
Yeah, so like Tara, I studied mechanical engineering as an undergrad. The Navy taught me about nuclear, which is, of course, has an incredible safety record. The Navy nuclear and the American, civil nuclear industry have better safety records than any other form of power generation. We have many veterans at TerraPower, I have to say, quite a few folks who are finishing their enlistments. We have a submarine base not far from our facility in Seattle, and we're thrilled to have veterans joining us.
You've talked about energy storage, you talked about the carbon benefits of nuclear power. Is nuclear power, particularly TerraPower's approach to it, is it green energy? Is that a term that could be used or that you use, or what do you think about that?
I absolutely think it's green energy. It's it's carbon-free emissions, right? So it's an excellent source of power for if you really want to reduce your
and
global
have
warming.
enough power to really, it has the oomph to power industry, and this incredible increase in electricity demand that is just inevitable. We know it's coming, it's already here.
That's right. So, I mean, we care a lot at TerraPower about the climate, but we also care a lot about energy security, and we're super concerned because the demand's growing, and if you look at Russia's attack on Ukraine and what that did to Europe's energy supply, it's a real message that we need sources like nuclear energy.
Chris Levesque's boss, Bill Gates, sees it the same way.
So this is a big step towards safe, abundant, zero carbon energy. And it's important for the future of this country that projects like this succeed. And that's because we're not just going to build one plant, we're going to build lots of these things. We're going to support electrification, we're going to support keeping the world's best data centers here in the country. And so we do need a lot more energy, and you're the pioneers that are going to make that happen.
Nuclear energy can't be interrupted by interrupting a rail line or interrupting a pipeline. When you load nuclear fuel in our reactor or even today's reactors, the 94 in the US, that's 2 years of energy in the vessel. That's 2 winters of heat. So nuclear has a great energy security story as well.
How do you assess the political environment for nuclear power here in 2024 and going forward?
I'd say a lot better than it used to be. Both parties seem to endorse nuclear because they do recognize the value that nuclear brings to what Chris had mentioned, both the climate issues and also to the energy security. And also, something that we kind of forget about is that when we produce electricity at reasonable costs within the United States, it's going to keep other industries here. Because energy is, all the big companies with all the high tech and everything, they're finding where there's energy so that they can locate. And,
Totally.
and that's really important. We want to keep jobs at home.
And we want our data at home too. Bill Gates talked about
point.
this today. If we're going to have our data centers in the US, we need electrons in the US.
Chris Levesque, Tara Nider, TerraPower, thanks very much. Congratulations on today and best wishes for what's coming in the years ahead.
Thank you
Thank
very
you
much.
so
Thanks
much.
for being with us on Wyoming Chronicle.